Hi everyone and welcome to my brand new C++ series. My name is Reza and in this video series I'm gonna teach you all you need to know about C++ from the very beginning and fundamental topics to more advanced ones. We are going to learn C++ more specifically in the context of software development for computer science and engineering applications. However, the topics I'm gonna cover in this video series will be like more generic, and you could apply this kind of understanding and knowledge for software development in wide range of applications using C++ programming language. Now, the main question you might ask, okay, why would I need to learn C++? Basically, if you want to write a fast code or you want to write a code for a specific computer architecture, you could use advanced and unique features of C++ programming language. And I would say in the context of writing a code for a specific computer architecture or in terms of software development for engineering applications, when you want to solve like some kind of complex problem, and you could use these kind of features which are specific for C++ programming language. An example of this would be like writing a parallelized code to solve a complex engineering problem, and you could distribute your problem between multiple nodes or processors using high performance computing features. Another advanced feature of C++ is the direct control of hardware. Let's say you write your C++ code in some sort of text editor or IDE. You pass your code into a compiler. Of course, we will in future video series we will have a discussion about how compiler works. The compiler will convert your C++ code into a machine code based on the architecture of your computer and the target platform like x64 or x86, and the machine code will be like the actual instruction that CPU executes. See how amazing is it? Using C++ programming language, you could execute and control all instructions that goes into the CPU and CPU executes. Of course, we all know that C++ is an object-oriented programming language, which we will have like discussion in future video series about the object-oriented programming languages, language features like abstraction, encapsulation, polymorphism, inheritance, and we should be careful about writing right code in C++. If we write a bad code in C++, of course the code will be like very slow, and therefore it is essential to know how to write a good code in C++, how to write C++ code correctly, how to write a fast code in C++, how to optimize the code writing in C++, and we are gonna learn all of this in this video series. Now you might ask what I'm gonna cover in this video series. I'm gonna start with very basic and fundamental topics related to, for example, let's say data types, variables, functions, conditions, if statements, while loop, for loops, and then moving forward I will talk about pointers, references, and related topics about the memory and smart pointers. I'm gonna talk about arrays, strings, and we will have in-depth discussion about struct, class, and advanced features of object-oriented programming language like encapsulation, inheritance, abstraction, polymorphism. And moving forward, I'm gonna cover advanced topics related to templates, which are extremely useful, and we will learn how to specialize template. I'm gonna talk about exception handling, recursion, linked list, and moving forward I'm gonna talk about C++ existing libraries and how to use this C++ libraries, and how to create link to this C++ libraries, and how to write a C++ code for specific applications. We are gonna cover all of these from very beginning and fundamental topics to advanced ones in these video series. For this video series, I'm gonna use GitHub to post the code related to each topics on GitHub, and then you could find the link somewhere below. And please make sure to subscribe the channel to get updates for upcoming videos. You could also follow me on LinkedIn, and the address is somewhere below. Now you might ask, who am I? I'm a research scientist at Johns Hopkins University. My research bridges the disciplines of computational mechanics, computational fluid dynamics, multi-scale multi-physics modeling, and design optimization of real-world engineering problems. And I use computer programming to develop some sort of modeling and simulation methodologies to simulate the performance of real-world engineering problems, and also in case of design optimization, how to optimize the performance for a given set of criteria. And of course, you could get more information about my research background on my LinkedIn, and also you could check my Google Scholar profile about what I have done in the past. Thank you so much, and looking forward to these video series. See you next time.